So guys, now please confirm to me. All of you get my voice on screen. Those who are attending in online, am I audible, guys? Now please confirm to me. All of you get my voice on screen. Those who are attending in online, am I audible? Is my voice on screen is clear to all of you guys? Please confirm to me. Everybody, guys, now please confirm to me. All of you get my voice on screen. Right. Good morning, guys. Yeah, sorry for the delay. And check it what we completed in the last session. So here the topic is differences between Java and others. The topics here we understood there. Okay. Differences between Java and others. In the differences between Java and others topic, already one difference we completed. Now we are going to understand the second difference, like preprocessor. That related point here we have to understand. Okay. Now let us understand the last class points now. Differences between Java and others, where the very first difference is C and C++ are static programming languages, but Java is what they're a dynamic programming language. Now, what is static programming language and what is dynamic programming language? If you understand it, if any programming language follows static memory allocation, if any programming language follows static memory allocation, then that programming language is what their static programming language. If the memory allocation is provided for the data at a compilation time, then that memory allocation is called what their static memory allocation. C and C++ are static programming languages. Why? Because in C and C++ applications, memory will be allocated at a compilation time only. Memory will be allocated at what time? No, compilation time only. If any programming language follows dynamic memory allocation, then that programming language is called a dynamic programming language. Alright, sir. Next one is if the memory allocation is provided for the data at runtime. If the memory allocation is provided for the data at runtime, then that memory allocation is called what their dynamic memory allocation. Right, sir. Java is a dynamic programming language. Why? Because in Java applications, memory will be allocated for the data at what time? Runtime only. Right. There, I given some diagrammatic representation, then how static memory allocation and how dynamic memory allocation and how static programming language and how dynamic programming language both are going to be happen. Already we had some discussion over this content here. Okay. All right, next one. Second point already just I started here. What is the point here I started here? Preprocessor is required in C and C++, but preprocessor does not required in Java. Preprocessor is required in C and C++, but preprocessor is not required in Java. Then immediately I given what is the location of the preprocessor. What is the location of the preprocessor? Preprocessor is the first phase in the compilation. Preprocessor is what there is the first phase in the compilation. Understand it clearly. There the diagrammatic representation also we have given. If we take C program and if we compile C program, there we are getting .exe file. When we execute this .exe file, automatically here we are going to get what their output. This is the actual structure. If you see the compilation process, in the compilation, how many phases are available? 4 phases are available. And compilation overall, 4 phases are available. What are the 4 phases of the compilation now? Preprocessor, compiler, assembler, loader, link editor. Understand it clearly? Overall, these 4 phases. First one is what there? Preprocessor. Second one is what there? Compiler, assembler, loader, link editor. Okay. Now this is our required part. Preprocessor is the first phase, in the compilation process. Everybody understand it clearly. After that, anyway, for the future purpose, I've given the compiler internal structure also. Now the compiler internal structure, if you understand it, no, nearly 6 pages are available here. One is what the lexical analysis phase, syntax analysis phase, semantic analysis phase, intermediate code generation, code optimization, then code generation. These are all 6 number of phases what we are having in our content. Is that clear? All of you are getting clarity on these points now, right? After this, after completion of this, now our requirement is what there. Preprocessor is not required in C, sorry, preprocessor is required in C and C++, but it is not required in Java. That's the actual point. Up to now, what we understood, what is the location of the preprocessor only we understood. Am I right or not? What is the location of the preprocessor? Only this point only here we understood. Okay. Now coming to the next point here. What is the purpose of the preprocessor? Location of the preprocessor is okay. Now we have to understand what is the purpose of the preprocessor. What is the purpose of the preprocessor? That point also we have to understand. See this, no, all of you here. In C and C++ applications, or maybe in C and C++ programming languages, the C and C++ programming languages, observe carefully. The complete predefined library, the complete predefined library was provided in the form of, tell me, the complete predefined library was provided in the form of what? In the form of header files. Am I right or not? In the form of what files there now? Header files. Right. Tell me examples for these header files now. What are the various examples for these header files? Can you just understand it clearly? Hash include, sorry, hash include is not required. stdio.h. Next one is what? After this, conio.h, conio.h. After this, math.h, and so on. So many things are available. These are the various header files which are available in the C and C++. See, not only in the case of C and C++, in every programming language, some predefined library is available. In every programming language, what is available there? Some predefined library is available. Okay. In C and C++, the predefined library is what? Header files. In the form of header files, the predefined library is available. But if you take the Java, in the case of Java, classes and interfaces in packages, that is different. If you go for some other programming languages, there may be some other representation is available. So, but final thing is what there, at each and every programming language, predefined library is available. How the predefined library is maintained is dependent on what their internals of the respective programming language. Good. Now, my requirement is what there. If you want to use this predefined library in a C or C++ program, first we have to include these header files into the C and C++ programs. First, we have to include these header files into the C and C++ files. Right. Now, all of you understand the point clearly. What I am telling there. If you want to if you want to use predefined libraries in the C and C++ applications, then we have to include the header files in the C and C++ programs. Right. Then we have to include the header files in the C and C++ programs. But how we are going to include the header files into the C and C++ programs now? How is it possible there? Alright, sir. Now here I'm giving clarity. For this, we have to use hash include statements. For this, we have to use like what there, hash include statements. Right, sir. Now understand it clearly. I'm going to use some hash include statements now. The very first one we can understand it now. Hash include stdio.h. Next one is hash include conio.h. That's okay. Next one is what there hash include math.h. Like this here, we are having some hash include statements. Everybody understand the point clearly, no? If we want to use predefined libraries in C and C++ applications, then we have to include the header files in C and C++ programs. For this, we have to use what there hash include statements. Then what are the various hash include statements here we are having there? Hash include stdio.h, hash include conio.h, and hash include math.h. So, all of you are getting it or not? Now, I'm going to talk about the actual functionality of the preprocessor. Now, try to understand it clearly. Say, for example, I have prepared a C program. I created a C program. In my C program, I have written these hash include statements. In my C program, I have written what their hash include statements. Understand it clearly. When I compile my C program, when I compile my C program, preprocessor is the first phase inside the compilation. Preprocessor will take the C program. Preprocessor will check hash include statements are available or not. If a hash include statements are available, preprocessor will take all the provided header files names. Preprocessor will go inside the C software where preprocessor will check whether these header files are existed or not. If these header files are not available, it will raise an error. If these header files are existed, then immediately preprocessor will load the provided header files content to the memory. Preprocessor will load the provided header files content to the memory. That means the total header file content is loaded to the memory. But this entire thing is going in at what time? They now tell me part of the compilation or not? Part of the compilation, preprocessor will load all header files content to the memory or not? So loading this header files content to the memory is nothing but loading library to the memory. Loading libraries to the memory. Loading libraries to the memory at a compilation time. Loading libraries to the memory at a compilation time is called static loading. Loading libraries to the memory at compilation time is called as what there? Static loading. That's it. Now there is a purpose of there's a functionality of the preprocessor. Come again. What is the job of the preprocessor here in our content now? All of you observe carefully. When we prepare a C program and when we compile C program, the first phase is what there? Preprocessor. Preprocessor will recognize all the hash include statements, takes all the provided header files names and go to the C software where it will search for these header files. If these header files are not available, then we are able to get some compilation error. If these header files are available, immediately preprocessor will load these header files content to the memory. Loading libraries to the memory at compilation time is called what there? Static loading. That's fine. Finally, this is the job of the preprocessor. In a short, preprocessor will load all header files content to the memory. That's it. Preprocessor will load all header files content to the memory. That's the functionality of the preprocessor. Yes, now let us move on to the same point here. No? If we compile C and C++ programs, then the preprocessor will perform then the preprocessor will perform the following will perform the following actions. What actions that preprocessor is able to perform there? Now observe carefully. Point number one: preprocessor will recognize all the hash include statements, and take the provided header files names. Next one is preprocessor will check whether the provided header files exist or not in a C and C++ softwares. Next one is preprocessor will preprocessor will okay, if the required header files exist at C and C++, okay, if the required header files do not exist At C and C++ softwares, then the preprocessor will raise an error. Right, sir. Next one is, if the required header files exist at C and C++ softwares, then the preprocessor will load the header files contained to the memory. Okay. Now here I am giving clarity. Now try to understand it clearly. Inside this, loading predefined libraries at a compilation time is called loading predefined libraries to the memory at a compilation time is called what there static loading. It's called what there static loading. Now I'm giving another conclusion. What is the need of the preprocessor in a C and C++? No, in a simple statement I'm giving there. Finally, therefore, the purpose of the preprocessor in a C and C++, or maybe instead of saying that, C and C++ require preprocessor to recognize hash include statements and to load header files content to the memory. Yes, sir. All of you are getting clarity on this. This is a conclusion here we have to understand. What is the conclusion here? C and C++ require preprocessor to recognize hash include statements and to load header files content to the memory. That's it. Just simply speaking, to load libraries to the memory, we require preprocessor in C and C++. That's it. Right? Can I move forward? Can I go for the next point here? No? Right. So then the diagram here I given clearly. This is in the form of like what there? C and C++. That's okay, fine. Similarly, I want to give the same diagrammatic representation for Java. In Java, how it is going to be happen. Now let me check for it. Right, sir. Now just 2 minutes of time. I'll prepare the same diagram here. I think I didn't save it yesterday, right? Have I saved it? No. No, I think I didn't save it. Yeah, no problem. Now let me check for it. 2 minutes of time. I'll complete it. Now I need to prepare this total diagram in the form of like what there Java. Understand it clearly. In the form of Java here, I'm going to prepare it. First of all, I'm going to take Java, for example. This is like what there Java program. Okay. Right. So now Java. When we have taken this Java file here, now we have to perform like what there compilation. Compilation. Okay. When we compile this Java file, there we are able to get one file. In the case of C and C++, we got like what there .exe files. In C and C++, we got what there .exe files. But in the case of Java, here we are able to get other type of files. Now understand it, no? The name of this other type of files are like what there .class files. What files here we are getting there? Class files. Observe carefully. Whenever we are getting .class files and when we execute these programs there, when we execute this program, now understand it clearly, this is execution process. When the .class files, if we execute there, then automatically here we are able to get some outputs. What outputs here we are able to get here? Now understand it, no? Output values here we have to get. That's it. Java program .java file compilation What files here we are getting there? Dot class. In the case of C and C++, dot exe. In the future, I will ask a question. What is it? What are the differences between dot exe files and dot class files? Dot exe files and dot class file. Ask that. So we have to answer for it later on. But first of all, understand it. No. So this is like what their Java file compilation dot class and execution. Now, if we take the compilation process, if we take the compilation process, in a compilation process, how many phases are available here in general? Actually, as per the basic concepts, four phases are available in general, as per the C and C++ awareness. What four phases are available here now? Understand it clearly. Preprocessor. Next one is what there? Next one is compiler. Next one is what there? Assembler. Then after this, what next one? Loader, link, editor. Loader, link, editor. So these are the four phases are available. Right. Sir. Now these are all like what there? Four phases are available. Now observe carefully. But now the point is what? What is the point here I'm telling there? In the case of Java, what is not available actually? What part is not available? Preprocessor is not existed. Preprocessor is not available. Simply speaking, what exactly the work which is done by preprocessor and C and C++ that could be performed by compiler and JVM in the Java. What exactly the work is available for preprocessor that will be taken care by compiler and JVM in Java. So no need to have what that preprocessor. And in the point of common sense, if you want to think about it, no, what exactly the work is done by preprocessor in C and C++, no, same thing is done by the same work could be performed by this is a compiler and JVM. So preprocessor is not required in the case of Java. But this is not the main reason. Still few more points I need to discuss with you now. Anyway, here we are getting the discussion here. So now my point is like what I'm telling to you. Then internal compiler internal structure also we I'm going to provide. What is the compiler internal structure here? If we take this compiler internal part again, no, then what we are going to have there? Now get now tell me inside the compiler structure, how many parts are available again? Six parts are available. What are the six parts? No, lexical analysis. Next one is what there? Syntax analysis. Next one is what there? Semantic analysis. After this, what next one here? No, intermediate code generation. Intermediate code generation. Then after this, code optimization. Code optimization. Then after this, code generation. Purposes are not required here. All these things, no, as of now, their intentions and their requirements, that means their purposes are not required. In the future, when I read the topic, there I will discuss with you regarding this lexical analysis phase, syntax analysis phase, and semantic analysis phase, intermediate code generation, code optimization, then after that code generation. All these concepts we will understand in the future. No need to worry at present here regarding this content now. Okay, now all of you observe carefully. Okay, now, so this is the total diagram what you are having. Now let me take this diagram first up about the Java. In the point of Java, how the structure is available, that information here I have discussed with you. Right, sir. Now, but now the point is what there. Now here we have to talk about it. Why preprocessor is not required in Java? Preprocessor is not required in Java. But why? What is the reason for it? I'll give some clarity. Understand it clearly. In Java, in Java, The complete predefined library was provided, the complete predefined library was provided in the form of in the form of classes and interfaces inside the packages. Strictly speaking, packages. But inside the package, what are available? Classes and interfaces are available. Okay. In Java, the complete predefined library was provided in the form of what there? Classes and interfaces inside the packages. Leave this punch here. Examples for the packages here I'm telling to you. What are the various examples for packages? No? Java.io, Java.util, Java dot something else like what there SQL. So different packages are available. That's what we understood clearly. And so on. So many packages are available, but some of the packages here are listed out. Java.io, Java.util, then what next one here? Java.sql. Getting my point clearly? Okay, fine. After this, after completion of these basic packages, no? But the point is what? If you want to use these packages in our Java programs, if you want to use these packages in our Java programs, we have to import these packages to the Java program. In a C and C++, including hash include statement. But now in the case of Java, the convention is changed. That means that syntax is changed. That is what there, not hash include statement. It should be like what there, import statement. Header files including, packages importing. Terminology here we have to understand. Right, sir. Now the point is what there, if you want to use libraries, if you want to use predefined libraries in Java applications, then we have to import the packages. Import the packages. For this, we have to use import statement. For this, we have to use what there? Import statements. What are the various import statements here we are getting there? Understand it clearly. Right, sir. What are the various import statements here we are getting there now? Now understand it clearly. Import java.io.star. Import java dot, then what next one here? Import java.io.star, java.sql.star. Then what next one here? Import. Then after this, java.util.star. Like this here, we are able to import the statements. Now here, I have a question. What is this star actually? What is the meaning of this star? Point is very simple. Package contains number of classes and interfaces. A single package can have more and more number of classes and interfaces. My requirement is I want to get all classes and interfaces from the provided packages. Java.io.star in the sense from Java.io package I want to get all classes and interfaces. Java.util.star in the sense I want to get all classes and interfaces from Java.util package. Java.sql.star in the sense I want to get all classes and interfaces from what there? Java.sql package. That's my main intention. Sir, got it? What I'm telling there? So here the point is like what there? Import java.io.star, import java.sql.star, import java.util.star. If we take it now, all classes and interfaces here we are able to get from what there? Java package, java.respective packages. No. That's the meaning here we have to understand about the star notation. Okay, fine, good. Listen, all of you listen carefully. I prepared a Java program. I prepared what there? Java program. Inside my Java program, I have included these import statements. Inside my Java program, I have included what there? These import statements. Okay, good. I compiled my program. I compiled my program. When we compile the program, remember carefully, preprocessor is not available. Then who is the first page here? What is the first page? No, compiler. Now, compiler will come to our Java program, will take our Java program. Compiler will recognize all the import statements. Compiler will take all the provided package names. Compiler will take all the provided package names from the import statements. Compiler will check whether these packages are available or not in the Java software. Compiler will check whether these packages are available or not in the Java software, almost the same as preprocessor functionality. But here changes are going in. Try to understand it now. If these packages are not available in the Java software, if these packages are not available in the Java software, their compiler will raise some errors. Package XXX does not exist. Error we are able to get. For example, if these packages are available inside the Java software, if these packages are available inside the Java software, then compiler will not raise any error. If these packages are available in Java software, compiler will not raise any error. Understand my point here? Compiler will not raise any error. At the same time, compiler will not load any package content to the memory. In C and C++, preprocessor will load that package content, that means header files content to the memory at compilation time itself. But in the case of Java, compiler is checking whether packages are available or not. That's it. Compiler is not loading any package content to the memory. Understand my point here? Compiler is not loading any package content to the memory. Compiler responsibility is only checking whether the packages are available or not. That's it. Clear. Now let me clear about this point here. When we compile Java program, when we compile a Java program, the compiler will perform the following actions. What actions the compiler will perform there now? Understand it clearly. The first one is, that first action is like what there? Number one, compiler will recognize all the import statements, and take the provided package names. Okay, compiler will check whether the provided packages exist or not in the Java software. Compiler will check whether the provided packages exist or not in the Java software. Observe carefully. Compiler will check whether the provided packages exist or not in the Java software. That's okay, fine. After completion of this point here, after understanding this, compiler packages are exist or not in the Java software. Okay, fine. If the required packages do not exist in a Java software, then the compiler will raise an error. Will raise an error like what? I'm giving that error also. Package XXX. Package XXX does not exist. This error here we are able to catch. Error message also I'm giving there. Now try to understand it clearly. Next one is, if the required packages exist in Java, in the Java software, if the required packages exist in Java software, then the compiler will not raise any error. Compiler will not raise any error. And at the same time, the compiler will not load any package content to the memory. And the compiler will not load any package content to the memory. Just compiler responsibility is only what they're checking whether the packages are available or not. Okay, compiler is not responsible for loading any predefined library to the memory. Okay, if the compiler is not responsible for it, if the compiler is not responsible for loading predefined library to the memory, then who is responsible for it? Exactly, right, sir. Now the point is what there? In Java, compiler is responsible for checking whether the packages are exist or not in a Java software. Compiler is responsible for in Java. Compiler is responsible for checking whether the packages are existed or not, whether the packages exist or not in Java software. Understand it clearly. All right, sir. Compiler is not responsible for loading packages to the memory. Okay, now the conclusion I'm telling there. In Java, JVM is responsible for loading predefined libraries, or maybe simply speaking, responsible for loading package content to the memory at runtime, that too as per the requirement only. It's not like on flow, as per the requirement. Which libraries we require, that libraries only it is going to load. Unnecessarily, it is not going to load all the statements. And one a simple point I'm telling there. Import statement is not loading any library to the memory. This import statement is what they're giving eligibility for us to use the classes and interface of that package. Yes, if you import a package, no, it gives that some access for us. Access in the sense what there now we can use classes and interface of that particular package. That's it. But import statement is not loading any package content to the memory. But when JVM is going to load the classes and interfaces to the memory there, when we use really the classes and interface in our Java program, no, then only JVM is going to load the respective classes and interfaces to the memory. Say for example, what I am telling to you, I have written this statement, import java.io.star. In java.io package, 100 classes and 100 interfaces are available. Understand my point, Keno? So what JVM will do, by seeing this one, compiler will check java.io is available or not. As available, leave it. But at runtime, JVM, when it encounters JVM will not load any content from java.io package. Because of import statement, JVM will not load anything. But really, in the remaining part of the program, really, if you use any class or interface from java.io package, no. Really, if we use any class or interface of java.io package, no. Now JVM will load the class or interface bytecode to the memory. When the class is going to be loaded, when we use that class in Java program. Because of import statement, the classes are not going to be loaded in Java. When we use classes and interface in Java program, then only that package, that class are going to be loaded. Example I'm telling you, observe carefully. Assume this is like what there, app.java. This is my application. Inside my application, what I have done there, import java.io.star, completed. Next one is what there, public class, say for example, app I have taken. Inside this public static void main string array args, for example, I'm going to take this. Args here I have taken. Then after this, what next one here we have to do there? Inside this, no, right sir. This is my program there. Okay, compiler will recognize this import statement. Compiler will check this package is available or not. Yes, package is available, no problem, leave it. When we execute the program, what is going to be happen? Say for example, system.out.println of just welcome message can I provide it. JVM will execute this main method directly. Inside the JVM is able to display what? Welcome only. JVM even will not touch this import statement directly. JVM will not touch this import statement directly. JVM will start program execution from main method. JVM will execute directly what there? Welcome. Now, I'm going to use a class from java.io package. Understand it clearly. Now I have used it. Buffered reader. BR is equal to new buffered reader. Then where new input stream reader. There we are going to provide what there? System.in. For example, one statement. One intersection Java. I have written like this. This is one simple line inside the Java that we have to understand. Observe carefully. This is a simple line in Java. Right. When JVM encounter this line, when JVM encounter this buffer data, now JVM will search for this buffer data in java.io. In java.io, hundreds of classes and interfaces are available. Now JVM required what? Buffer data. Now JVM will search for this buffer data in what? Java.io package. Now JVM will load that buffer data class bytecode to the memory. After that, again buffer data already loaded. Now JVM encounter what their input stream reader. Now JVM will search for this input stream reader in java.io package. Now JVM will load that input stream reader content to the memory. Sir, all of you get my point or not? So because of this import statement, JVM will not load anything to the memory. But because of using the required library inside the Java program only, the respective class or interface are going to be loaded. Yes, sir, got it or not? So this is about like what the requirement, what actually the point here I'm trying to say. Now understand it clearly. Okay, leave this one here. What is the conclusion here I've given there? In Java, compiler is responsible for checking whether the packages exist or not in Java software. Compiler is not responsible for loading packages to the memory. In Java, JVM is responsible for loading package content to the memory at runtime as per the requirement only. Right now, I'm going to give conclusion there. Now tell me, what is the conclusion here I'm telling you? Observe carefully. In Java, all of you observe carefully. In Java, preprocessor is not required. In Java, what is not required? Preprocessor is not required. Why? Because. What is the reason for it? No. Why? Because in Java, hash include statement and header files are not existed. Why? Because in Java, hash include statements and header files are not existed. Okay, fine. Alternatively, what are available? Alternatively, Java has right. What next one here? Classes and interfaces in packages. Classes and interfaces in packages, and the classes and interface in packages, and the compiler and JVM, That's it. Compiler and JVM are existed. Why? Because what is the reason here I'm telling there? In Java, preprocessor is not required. Why? Because in Java, hash include statements and header files are not existed. Alternatively, Java has the classes and interfaces in packages with import statements. Instead of that, class and interface in packages with import statement. Not like compile and JVM, right? Then at the same time, then what next one here we are providing there no after completion of this content here, what next one here I'm telling there, to recognize and load, to recognize libraries and to load the libraries, already compile and JVM is available, they are sufficient for us. Because of that reason, preprocessor is not at all required. Yes, sir. Got it? What I'm telling to you. So this is about our content here related to Java, and it's a preprocessor requirement inside the Java programming language. Completed, sir. This part is completed. Okay, fine. Now, here I'm getting one important interview question. We have to answer for it. What is the question here we are getting there? Observe carefully. Here my question is, what are the differences between hash include statement and import statement? What are the differences between hash include statement and import statement? Right. And before this, one more point here I have to cover here. Yeah. Now here, another point here I'm getting there. In Java, compiler is not responsible for checking whether packages exist or not in Java software. But compiler is not responsible for loading packages to the memory. In Java, JVM is responsible for loading packages to the memory at a runtime as per the requirement. Here the point is what there. Loading predefined libraries to the memory at a runtime. At a runtime of the applications is called dynamic loading. Loading libraries at runtime is called what there? Dynamic loading. Now tell me, which languages are following static loading? C and C++. C and C++ are following what there? Static loading. Which languages are following dynamic loading? Java. Java is following like what there? Dynamic loading. C and C++ are following what there? Static loading. Java is following what there? Dynamic loading. All of you are getting it or not? Right, sir. Now, the points here I am telling there, in Java, preprocessor is not required. Why? Because in Java, hash include statements and header files do not exist. Alternatively, Java has classes and interface and packages with the import statements. That's okay, fine. Right, sir. Now here we are getting this diagram here. For the diagram, I have given some clarity. Now try to understand it clearly. Okay, fine, no problem. So this is a diagram here. Then after this, now immediately we have a question. What are the differences between hash include statement and import statement? Right. I'll give some points to you, now try to understand it clearly. Point number one, very carefully. Hash include statements exist in C and C++. Am I right? They are available in C and C++ only. Next one is what their import statements exist in Java. Import statements exist in what there? Java. Next one is hash include statements exist in C and C++ and import statements exist in what there? Java. Next one is hash include statements are used to include the predefined libraries are used to include the predefined libraries to the memory predefined libraries to the memory which are available which exists in the form of header files. Is it? Am I right? Now observe carefully. Hash include statements are used to include the predefined libraries to the memory which exists in the form of like what their header files. Clear? Next one is similarly import statements are used to include the predefined libraries, include the predefined libraries to the memory which exists in the form of, I think this is somewhat a wrong statement here, what I am giving there. Uh, right, so now hash include statements are used to include the predefined libraries which are available, include the predefined libraries which are available, which exist in the form of header files. That's nice, which exists. Import statements are used to include the predefined libraries which exist, not to the memory. That's not right. Which exists in the form of classes and interfaces in packages. Classes and interfaces in what their packages. That's it. Now this is a point number two that we have to understand clearly. Next one is after this point number three. Supporting what type of loading? Or maybe before that, hash include statements are evaluated by the preprocessor. Am I right? Hash include statements are evaluated by whom? Preprocessor. Now, import statements import statements are evaluated by both evaluated by the both compiler and JVM, both compiler and as well as like what their JVM. Right. This is another point. Now the next one here. All of you understand it clearly. After this, static loading or dynamic loading. Which one is supporting static loading and which one is supporting dynamic loading? If you understand it, no? Hash include statements supports static loading. Hash include statement supports what there? Static loading. Of course, done through C and C++ program only, but they are supporting static loading. Next one is what there? Import statements support dynamic loading. Import statements support like what there? Dynamic loading. Okay, fine. Next one more point. Here I'm telling you, observe carefully. Now, I'm going to ask one question to you, now try to answer for it. I think you're already aware about C and C++, no? That's why I'm asking this question to you. Now try to answer for it. Say for example, hash includes stdio.h, comma, anio.h, comma, math.h. Is it possible? That means indirectly what I am asking there, is it possible to include more than one header file by using single hash include statement? No, not possible. In the case of C and C++, it is not possible. But what is possible in the case of C and C++? No. If you want to include one particular header file, there we have to use one separate hash include statement. One separate hash include statements here we have to use. Next one is what there? Hash include math.h. Like this here we are providing like what there? Some content. I forget my point or not. So here the point like what I am telling there. In a C and C++ programs, in a C and C++ programs, to include more than one header file, to include more than one header file, more than one header files, we have to use more than one hash include statements. We have to use what there more than one hash include statements. Then examples can be provided here. Now observe carefully. In C and C++ programs, to include more than one header files, we have to use more than one hash include statements. Now get example here I've given. So these are the examples here that we have to understand clearly. Next one is after that. But in the case of Java, what's going on here? In the case of Java, now tell me. In Java applications, in Java applications, by using single import statement, common import statements, no? By using single import statement, we are able to import more than one class or more than one interface of the same package by using star notation Right, sir. Now, in Java applications, what we have to do there in this scenario, in Java applications, by using single import statement, we are able to import more than one class or more than one interface of the same package by using what notation here? No, star notation. Now, example, here I'm telling to you, understand it clearly. Example, import java.io.star. Here star is available. Inside this java.io, hundreds of classes and interfaces are available. All of them I'm able to get. I'm able to use them now as per this import statement. That's it. Now this is a clear-cut analysis about like what there hash include statement and import statement. Then what we are getting clearly now. Right. So finally, the second difference is completed. The second step is completed totally. Now observe carefully. What is the second step here? I am telling to you now. Understand it clearly. Right, sir. You see this punch here. Preprocessor is required in C and C++, but preprocessor does not required in Java. That's the point, sir. Then what I have given there? First of all, what is the location of the preprocessor? Preprocessor is the first phase in the compilation. Nice. What is the next point here? What is the purpose of the preprocessor? I have discussed it here. In C and C++ programming languages, the complete predefined library was provided in the form of header files. stdio.h, conv.h, and math.h. If we want to use predefined libraries in C and C++ applications, then we have to include the header files in C and C++ programs. For this, we have to use what there hash include statement. Hash include stdio.h, hash include conv.h, hash include math.h. Okay. Next one is if we compile C and C++ programs, then the preprocessor will perform the following actions. What actions are performed by preprocessor here? Preprocessor will recognize all the hash include statements and take the provided header files names. Preprocessor will check whether the provided header files exist or not in C and C++ software. If the required header files do not exist at C and C++ software, then the preprocessor will raise an error. If the required header files exist there, then preprocessor will not raise any error. If the required header files are not existed, error will come there. If the required header files are available, preprocessor will load the header files content to the memory. Understand it? So loading predefined libraries to the memory at compilation time is called what there? Static loading. Right, sir. In C and C++, C and C++ required preprocessor to load, to recognize hash include statements and to load header files content to the memory. Then examples can be given there clearly. Now coming to the Java. In Java, the complete libraries are available in the form of classes and interfaces in packages. Okay, then some examples here are given there. But if you want to use these libraries in Java programs, there we have to use what statements there? Import statements. Import java.io.star, import java.util.star, import java.sql.star. When we compile Java program, then the compiler will perform the actions. Compiler will check, will recognize all the import statements. Compiler will take the package names. Compiler will check whether these packages are available or not. If these packages are not available, compiler will raise an error. If these packages are available already, compiler will not raise any error. At the same time, compiler will not load any package content to the memory. In Java, compiler is not responsible for loading packages to the memory. In Java, JVM is responsible for loading packages to the memory. At what time here? At runtime, not even at a compilation time. At runtime, JVM is responsible for loading predefined libraries to the memory. Okay, right, sir. Loading libraries to the memory at runtime is called what there? Dynamic loading. In Java, preprocessor is not required. Why? Because in Java, hash include statements and header files do not exist. Alternatively, Java has classes and interfaces with what statements there? Import statements. Alright, so diagrammatic representation I've given. Then after this, what are the differences between hash include statement and import statement? That points here we understood. Hash include statements exist in C and C++, but whereas import statements exist in what there? Java. Hash include statements are used to include the predefined libraries which exist in the form of header files, whereas import statements exist. Import statements are used to include header files, that means predefined libraries which exist in the form of what there? Classes and interface in packages. Hash include statements are evaluated by preprocessor. Import statements are evaluated by both compiler and JVM. Hash include statements support static loading. Import statements support what their dynamic loading. In a C and C++ programs, to include more than one header files, we have to use more than one hash include statements. Example are given there. But in Java applications, by using single import statements, we are able to import more than one class or more than one interface of the same package by using what notation here? Star notation. Import java.ivo.star. That information here we have given there. Right, so this is completed. Second difference is completed. Now the third difference is like what then? At least we are going to see the title of it. Now try to understand it. No. Third difference is like what there? C and C++ are platform dependent programming languages. Important difference. That's it. In the differences between Java and others, in the overall differences, no, this is one of the important difference that we have to understand. C and C++ are what their platform dependent programming languages. But Java is a platform independent programming languages. Java is a platform independent programming language. That's it. Now understand it clearly. C and C++ are platform dependent programming languages, but Java is a platform independent programming language. Now here we have to understand how C and C++ are platform dependent and how Java is a platform independent. That content here we have to understand. At least now definitions, no? Now tell me, at least definitions here we are going to see. What is platform dependent programming language? What is the meaning of this platform dependent programming language? Right, I'm giving clarity. If any programming language, if any programming language allows its applications to perform, compilation is on one operating system. Sorry, compilation and execution both are on the same operating system, not on two different operating systems. Compilation and execution both must be performed on the same operating system. Then that programming language is what? Platform dependent programming language. Tell me again, what is platform dependent programming language? If any programming language allows its applications to perform compilation and execution, both must be on the same operating system, not on two different operating systems, on the same operating system. Then the programming language is what their platform dependent programming language. Similarly, what is platform independent programming language? If any programming language allows its applications to perform, compilation is on one operating system, execution is on another operating system. Compilation is on one operating system, execution is on what there? Another operating system. Then that programming language is called what there? Platform independent programming language. But here the question is, definitions are okay, but how C and C++ are platform dependent programming languages? How C and C++ are platform dependent programming languages and how Java is platform independent programming languages. That points here we have to understand clearly. Is it okay? So do one thing. Then if I start this content, it may take time here. So tomorrow I'll explain. 1 minute, 1 minute, 1 minute, 1 minute. Tomorrow is Saturday, right? Actually, I need to take the class on tomorrow. Definitely, as per the schedule, up to Saturday I have to take the class. No, but tomorrow is excuse. Why? Because I'm using GoToWebinar software at present. I think then online class is also be running there. I'm using GoToWebinar software. Tomorrow, that GoToWebinar people are doing some maintenance over their product. That tomorrow totally that software is off. So even not possible to record our sessions, not possible to conduct that online classes now. So give gap on tomorrow only. That's it. So tomorrow and day after tomorrow, no classes for us. Sunday anyway, official gap. Then tomorrow is because of this maintenance. I'm not going to take this class now. Next class will be on Monday. Next class will be on what day? Monday. The Monday, I think so. There is a festival, right? The Raksha Bandhan, right? But still, I'm ready to take the classes now. But 3 days of time, all days is not suggestible. It's a matter of 1 hour class, 1.5 hour class now. At early morning class, come to the class, complete it, then you can go for festival again. Nothing is going to be happen there, right? Understand it? What I'm telling them, right? Come for the class. On Monday, we'll take the class. Monday, we are going to see the content continuation part of this one. Okay, right, sir. That's all. We'll meet on Monday again. Thank you. Yeah, then Devender, these class videos are provided by our admin people actually. Our admin people will talk with you regarding that. That means they will share that videos link to you. So the whatever the link I have given there is a class notes only, and not like what they videos link. Our admin people will share that videos link to you. No need to worry for it. Okay. I think already our people might be submitted some videos link to you to all the members there. Please check once in our mails now. Then definitely then our admin people has to submit that links to you now. Okay, just please talk with one time with our admin people there, then they will share with you. Yeah, thank you. Thanks a lot.